Sunil, you want to say something?
Yeah, can I ask you something?
Yes, yes.
One thing is that assignment 10, there were some two answers confusing.
Last question. Ninth question.
Yeah, last.
Yes, that we had discussed, right?
Sorry, assignment week 11.
Week 11. Let me open the question.
Fifth question. During off-peak hours, which operation is desired from a microgrid?
Just, okay, so which one?
Fifth question.
Yes, which one? Which answer you think is correct?
Actually, it is when during off-peak hours, should consume power from the conventional grid and charge the batteries.
Yes, correct. Supplying power to conventional grid will be there for peak hours.
During peak hours.
This answer should be B.
Answer should be B.
Yes.
And the sixth question also, for developing various control mechanisms. Sorry, that is okay. Next, eighth question, who determines the preferred demand volume and time duration? See, the answer is independent system operator. It's not distributed system operator. So the choice is not there in here.
Option is not available. So none of the above. Yes,
None of the above. These two questions are related to this assignment. And one more thing, sir. We cannot able to download the 10th week 10 and 11, 12 videos.
Week 10, 11, and 12. All the 3 weeks.
Pardon?
For all the 3 weeks, you are not able to download.
All the videos, week 10, 11, 12, 3 weeks videos, it is directing to some other URL, but there also we cannot find the actual videos. The name is showing same, but when you go to inside that video, it is giving older video. So related to some other subject.
So you can download it from YouTube then.
Okay. Is it not possible to the way earlier we were downloading?
It will take some time. So,
see, there it is showing the videos, but when you click on that video, it is giving to
some
other
other
link. Yeah. There, I think that was the earlier proposed scheme. Only till 40 lessons are available. Till 8 weeks.
Is, yes. There are 2 playlists on YouTube. One is for 41 lectures and one is for 61 lectures. So when you are trying to download, it is taking it to same the previous playlist. That is the problem.
So if you get that 60 videos link, then it will be easy.
That is available on.
Thank you.
Have you checked that on YouTube?
Pardon?
Did you check the videos on YouTube?
Yeah, YouTube I have checked. But it is more convenient to download from this site, NPTEL.
Because if on YouTube we don't have any option to download.
Yeah, just only it is streaming.
We have to go to some other site for downloading.
And these 3 weeks videos are very critical to understand the subject with the demonstration and simulation results. And every time it is not possible to log into online also.
Correct.
If it is possible, you can make a chance to download.
So by the time it is updated, you can directly watch it from YouTube. Mm, Today, my voice may not be that clear. I have some problem in my throat, so please bear with me.
Okay.
Shall we start? So let us start today's session. Welcome all of you for week 11 of live session of Advanced Research Trends in Smart Grid Technologies. I'm Gagan Meena and I'm a PhD student in Electrical Engineering Department at IIT Bombay. I'll follow this agenda which we have been following for previous weeks also. So we will be first going through the overview of week 11 and then we will discuss some questions. And then some, if you have any doubts, you can ask. I hope all of you will have submitted the assignment. But if not, then tomorrow is the last date. So please submit the assignment. And the recordings for all the previous sessions as well as for this session is available on this URL. It's also available in the on the portal. You can download, go through them. So let us start with week 11 overview. So in week 11 we discussed these four topics. First was the energy management of DC microgrid and design of smart grid and practical case study. System analysis of AC/DC smart grid. In system analysis, we discussed mainly the power flow analysis. Can any of you tell why do we can we use the same methods for power flow that we use in transmission system? In transmission system, we use these methods in Newton-Raphson, Gauss-Seidel, or fast decoupled load flow. All these methods we use for transmission system load flow or power flow. All this, the power flow studies are required to know the one application is state estimation. To know the states, then to simulate different scenarios. Then optimal power flow is also this is very much important for the operation of the power system. All the parameters like delta, which is the angle, voltage limits, other tap changing transformers, their taps are there. All these should be within their band. Line flow limits are there. They have to be within their limits. And in optimal power flow, most of the time there can be several objectives. But most common objective is to minimize the overall cost function. This cost is the generation cost. In transmission system, we can use all these methods, but these methods we cannot use directly in for distribution system. What is the reason behind that? Can anyone of you recall? You cannot use them directly. There is one major difference between transmission system and distribution system, and that is an important factor because of which we are not able to use these methods directly. That is the X by R ratio, or R by X we can say. So this X by R ratio is high in transmission system. And because of that, we are able to make certain assumptions. We are able to use this fast decoupled load flow and other things. Certain assumptions that we make for simplifying our power flow equations in transmission system, we cannot do that in distribution system. Distribution system resistance is much higher than the inductance. And if we use the same methods that we are using for transmission system, then there will be issue in convergence. The load flow, power flow problem may not even converge. We have to use other methods for distribution system. So there are several methods. One which was mentioned in lecture was forward backward sweep. Then there are other methods also like implicit Gauss. One is direct load flow. These are some methods which we can use for power flow analysis in distribution systems. Then the last topic was the demonstration of grid connected DC microgrid. The main component in the grid connected DC microgrid is the power flow control strategy block. It performs several important functions which are required for the efficient operation of the system. So as we have seen in previous week also that one of the main objectives of the operator is to ensure peak demand reduction. So do you remember why do we want to minimize this peak demand? what are the benefits that we achieve by reducing peak demand? Anyone of you? Operating cost reduction. How operating costs will reduce? A system operator gets benefited because if we have this, suppose we have not using peaking units, that is correct. We are not using peaking units. Sorry. One is this load profile, another is this one. So if we have a flat load profile, then we know that load will always be almost near this. It will follow this curve. So we can design, we can keep the installed capacity as per this demand. And we can also see that for this flat curve, all the generators will be used to their optimal extent. But if we see this second curve, this curve, then we can see this is the base load. So generators which are being used here, they will be utilized properly. But for this region, one thing is that we need more generation for this period of time. For some small duration of the entire day. First of all, they are used only for a short duration. That is why their efficiency is less. Means they will, so it will be a inefficient operation for them. This will increase the cost for the system operator. And generally speak, also because we need to provide this peaking generation. These generators are also gas-based, or gas-based generators are costly because from here we need quick ramping, which thermal generators may not be able to provide. If we need high ramping, then we have to use these generators, or hydro we can use. So operator always wants to have a flat load profile. Flat load profile is the ideal one. We cannot achieve. It's very difficult to achieve. Okay. But we can try to reduce this peak by different types of demand response techniques or demand side management techniques that we have studied in the previous week. So one first is this. So this peak reduction is main objective of this. Then it also helps in smoothing, making the transition between different modes smoother. And it provides effective control and management. It also takes care of the battery degradation. So it will charge or discharge battery in a way that the life span of battery is increased. Degradation reduces. Because for a battery, number of charging and discharging cycles are fixed. So based upon the depth of discharge and the discharge rate, these two factors highly determine the battery degradation. If we are able to ensure these two within their limits, then can ensure a good battery lifespan. Then it increases the same. If it reduces stress on batteries, so lifespan will increase. Then covering both grid connected islanded modes and then providing unity power factor or drawing unity power factor power from grid. This is the block diagram for the power flow control strategy for achieving all those objectives that were discussed in the previous slide. So here we have three different modes. So one is peak hour, off peak hour, and isolated mode. These two are for the grid connected, and this is for isolated or islanded mode. Uh, so, do you want me to explain uh, this flowchart? So, let us quickly go through this. So, first of all, we are checking whether the grid is available or not. So, if grid is available, we have two options, either peak hour or off peak hour mode. Then, so we check which is it a peak hour. If yes, then we have to check. So this peak hour is for grid. So the conventional grid to which the microgrid is connected. So this conventional grid is observing peak hour. Peak hour means the load is at its highest maximum value at that hour. So if the load is maximum, what do we want? We always want the generation and load to be balanced. So if load is high, we want generation to be high. But if we are not having that much generation, then the microgrid can help in providing that difference between these two. So this is for the grid. So this difference microgrid can provide. So here we are checking whether the generation from the PV is greater than load. If it is greater than load, then we check the storage. If storage SOC is more than 70%, then grid can absorb. So microgrid can supply power to the grid. And in this case, PV is always operating at the MPTEL. So whenever so PV is connected to grid, in grid connected mode, PV will always be operating in the maximum power point mode. Because whatever is generated by PV, either we can store it in the battery. If the SOC of battery is already fully charged, then we can supply it to the grid. If battery is not charged, then the battery can be charged. So it will always operate in maximum power point mode so that it can extract maximum power, either to charge the battery or to supply to the main grid. So if SOC is less than 70%, then battery can be charged. The grid is disconnected. So the main objective of peak hour mode is to either to supply power to the grid if sufficient generation is available. If sufficient generation is not available, then minimum power should be taken from the grid, because grid is already under stress. We don't want to stress the grid further. That is the main objective of microgrid. If it is able to supply the load locally, then we can reduce the stress on the grid. Or we can avoid that stressing the grid. The generation is not more than the load. That means the load is more than generation. Then battery has to. Then we have to again check the storage. What is the SOC? If SOC is not less than 30%, then it can discharge and supply all the load, full load. But if it is less than 30%, then we have to see how much less is it. And based upon the SOC, it will be decided which load can be supplied. So we have to supply the critical load. The critical load has to be always supplied, or here it is essential load. So in all the three cases, we can see essential load is being supplied. That we have to ensure. This is for the peak hour. Similarly, it is also for the off-peak hour. In off-peak hour, grid is not under stress. So how can we decide? How can we know that it's a peak hour? What parameter can help us determine whether it's a peak hour or off-peak hour? Anyone of you? Can you recall? Yes, that is correct. One thing is we can see the tariff. Generally, during the peak hours, prices will be high. It generally follows the demand curve. May not always be true, but generally the price curve also follows the demand curve. So during the peak hour, the price will be high because the distribution companies, they want to supply their load. So they are ready to pay a good amount of price. So market is clear at a very high price during peak hours. Another thing we can check is frequency. Right? In peak hours, if generation is less than load, and the frequency will reduce. In off-peak hour, generally in off-peak hour generation will be more than the load. That also we can do. So in off-peak hour, we can use the extra generation available on the grid side to charge the battery, so that during peak hours the battery can be used to supply load within the microgrid. Is it okay? If, if grid is not available, then this is the isolated mode or the islanded mode. In islanded mode, if the generation is more than the load, and SOC also is more than 90%, that means battery is already fully charged. So the PV no need to operate at maximum power point because generation is already more than load. Only battery was there to absorb the power, but now battery is also fully charged. So that extra additional power extracted from PV will not be utilized. So it will be curtailed. So we shift from MPPT to the off MPPT mode. If it is not more than 90%, then battery will be charged and PV will operate at MPV to charge the battery. So if PV generation is more and battery is fully charged, PV will operate in off MPPT. Otherwise, if PV generation is less than load, then PV has to operate at maximum power point and rest will be supplied by the battery. Is there any doubt in this project? So let us move to next. Then the demonstration was made for smart grid in which several different components were used. So this is a list of all the components. RTDS we have seen in previous lectures also. It's a very high, very fast processor. We can simulate our system in RTDS. And then we can take output to perform different types of hardware input simulations also. So one of the limitation for RTDS is that in the video which we in the system that was shown in the lecture, it consisted of 6 racks. Each rack is having a limit of 72 nodes. Six racks can only simulate a system which has 432 nodes. Beyond that, RTDS will not be able to simulate. And these are the different analog output, digital output, analog input, digital input cards, which are used for either taking input from any other in the loop, and we do hardware in loop simulations. Or even if in open loop, we can take inputs from outside, and we can also give output for the external requirements. Then the next important component which is used for power hardware in loop, it is the power amplifier, because the output of these RTDS or Opel RT is limited. The voltage they have maximum plus minus 10 volts output. But if you want to operate or test a practical relay or any other protection device, then we need higher voltages, higher power. For that we need power amplifier. We have to amplify the power using these power amplifiers, so that we can connect the output of our amplifier is suitable for the device which is under test. So it can support up to 270 volts RMS and DC of 400 volts and different power factors. Then for doing any kind of study, we need, in microgrid we have different types of renewable energy resources, PV, wind, but it may not be available that cannot be present inside a lab. So they are outside. PV can be on the rooftop. But if you want to have anything inside lab, then we have to use the simulators which will behave as per the actual PV which is there on rooftop. So these simulators will simulate the real-time weather, even shading effects. Whenever we plan the PV panel over rooftop or even in open area, those solar farms, we have to ensure that the place where we are installing the solar panels, they are free from any kind of shadow. The shadow analysis is done for solar panels. For both solar farms as well as the rooftop PVs. Because if there is shading on one cell, that will limit the output from the this entire room. Also, it will create hotspots, heating, local heating effects. So all this deteriorates the life of the PV panel. We want to minimize all these things. This also can be simulated in shading effects. And even after having shading, we want to extract maximum power. So for that, static and dynamic MPPT is also required. So dynamic is required when there is a continuous change in cloud cover or there is shading effect. So continuously it has to change itself. Similarly for wind also, just as shadow analysis is done for solar PV, for wind also, there is certain distance between two windmills. The way in which the windmills are aligned, that also very much affects the output of the wind turbines. Their arrangement has to be very optimal for for wind turbines also. For wind also, we can use the emulator. This is DFIG based, which is a type 3 wind turbine. In previous lectures, we have seen there are four types of wind turbine, 1, 2, up to 4. 4 is the PMSG based, permanent magnet synchronous generator based. DFIG is the third type, induction generator based. Here also we need maximum power point tracking, and this can also simulate the real wind and scenarios. Then, if small rooftop PV can also be connected to the test bench, then a diesel generator was also there. Different types of storage can be used, like lead acid, ultra capacitor. Now lithium ion is also there. Then different types of loads. This also we have seen constant power, constant impedance, and constant current load. These different types of loads are there in actual. When we do power flow analysis for transmission system, we consider that all the loads are constant power load. We make that assumption. By aggregating all the distribution load, we consider that it is on an on a broader scale, it is taking a constant power from the grid. So we consider it as only a constant power. But while doing distribution system analysis, power flow analysis for distribution system, for AC or for AC DC, we have to use these different types of loads, model them as per their original characteristics. The storage. So then another thing is converters. Now let us move to hardware in loop. So in hardware in loop there are two types. One is control hardware in loop, which we have seen in previous videos, previous week. And next is the power hardware in loop. So both these can be open loop and closed loop. If it is open loop, that means it is only taking some input, but there is no feedback. Similarly, closed loop, there is some feedback for correction. So why do we use hardware in loop test? Can anyone of you recall? Why do we use these simulations? What is the benefit of using these simulations? If we want to test a relay, suppose a new relay we want to test, so we cannot go and install directly it into substation and see if it maloperates, then it will create problem with the operation of the entire system. So before actually installing these instruments in the system, these hardware in loop simulations are done to verify their performance, and then they are actually installed in the system. The different types of scenarios are considered while doing these hardware in loop tests so that they can be verified for all the different possibilities of situation that may occur. So these are safer to test. We can do them because these RTDS, they are operating at very low voltages, and we have power amplifier. Then we are testing these. So for even protection system, we don't even need these. We can directly use the output of RTDS to test them. For testing these power devices like motors, inverters, that for that we need power hardware in loop, because these protection or control devices, they operate at lower voltages, so they can be directly be used. So physical control or protection relay devices can be interfaced directly with RTS, real-time simulators, and thus they can exchange these signals because these voltage levels are very small. But for doing a simulation with the motor inverters, we cannot do that. They require full three-phase voltage, or even if we are doing it for a single phase, it will require 230 volts. The output of RTDS is only limited to 10 volts. We need to amplify that. So for power hardware in loop, we require a power amplifier. So this is the same depiction of CHIL and PHIL. So even if we require an amplifier here, that would be of very small size. Its rating will be very small. We will not require a big amplifier. But here we will require very high rating amplifier. And here we also need this voltage and current sensor for sensing high amount of voltage and current. Then we discuss AC/DC distribution network. So, can anyone of you tell why are we going for a hybrid of AC and DC network? Why not go for DC microgrid?
so that we can get the benefit of both AC as well as DC.
Okay, so what will be that benefit?
When we can get the direct power from means for wind turbine, we can directly connect to the grid, so no need of converting into the AC to DC. And somewhere in case of power means a PV system, we can directly feed into the system.
Yes, because so what reason is correct? Because we have now increased number of sources and several loads over several electronic. Most of the systems, the loads that we use nowadays are powered by these SLPS. They are electronic based. They all need DC supply, and for that we use the SLPS. If we have DC supply available, we don't need that. We can directly supply that. So we can avoid the different conversion stages, and that will improve the efficiency. But however, we cannot replace the entire AC grid that we have. So the hybrid is a good option because we still have AC generators. Most of our bulk generation that happens is AC, and the transmission also long distance transmission that we are using, that is also having a combination. Mostly it is HVAC or UHVAC or EHVAC. We have HVDCs also, but mostly they are. Our transmission system is also AC. So we cannot replace our existing AC system. We can use these hybrid microgrids at distribution levels. So here these orange ones are the AC buses, rest are DC, blue are DC. So wind output can be directly fed PV. It will go through conversion because it is DC and it is we are connecting it to AC. Similarly, others also. So these are the different types of component that are there. The next thing is the when so this topic is mainly for the power flow analysis, the system analysis of AC/DC distribution network. When we are doing power flow analysis, the first step is to classify the buses. So can anyone of you tell why do we need to classify these buses? Can we not solve the power flow equations without classification of these buses?
Sir, what is the question, sir?
I'm asking why do we need to classify the buses for power flow analysis?
Sir, if we are doing for the load flow analysis, in that case, we need to specify the slack bus as well as the load bus and generating bus,
Yes, but
like Newton-Raphson Gauss-Seidel method in that case.
so my
In case
question
of
is why do we have to specify that? That is the question.
Because DC bus there won't be any frequency.
Oh, just let us first, even if there are no DC buses, if we, when we do power flow analysis for transmission system, also we have AC buses. For AC buses also we do these classifications. So why do we do this classification? Even for AC buses. Is it that without this classification we will not be able to solve the power flow equations? Is there any relation between that? Or we just do it?
Sir, the slack bus is defined to control, means maintain the losses, whatever the losses happen in the.
That is one reason for slack bus. Yeah, that is for slack bus. Another reason for slack bus is to make a reference for angle for other buses. So that is for slack bus. Still, other classification is still there. So the basic reason for doing this classification is when we write the equations for the power flow equations, then the number of unknowns and the number of equations, they are not equal. Number of unknowns are more than the number of equations. So we have to specify them some of the way, some things. For each bus we have what we want to know. We want to know P, Q, V and delta. Okay, 4 variables are there. But for each of these type of buses, we specify 2 of them, so that the number of equations and number of unknowns become equal. In slack bus, what are the specified values for slack bus?
V delta.
Correct. It is V delta. So we consider it as one angle 0. We call it flat start also. Then for load buses,
PQ.
PQ is specified. We have to calculate voltage and angle. And for voltage controlled buses,
It's PV.
yes, for PV. So for generation, these are also generation buses or voltage controlled buses. So PV is specified. So we can calculate Q and delta. Here we calculate P and Q. So now we are able to calculate all the things. Once all these things are known, we can calculate power flow also. So that is the main reason. So without classification, we will not be able to solve. So similarly for DC buses also require this classification, and since in DC there is no frequency, so Q and delta is not there. The reactive power is not there and delta is not there. So there are only 2 type of buses. One is P is specified for loads and voltage is specified for voltage control buses. So is this clear? Yes, so that is, we will discuss this in a slide also. This is for transmission system. This is for distribution. It's AC distribution also. The load flow solutions equation, the methods that we were using, we use for transmission system, Newton-Raphson, Gauss-Seidel, fast decoupled, that we cannot use here in distribution system. Because in transmission system R by X is small, because of which we are able to make certain assumptions that do not hold true for distribution system. And if we use same methods, we will face problem in convergence. So we have to, because of high R by X ratio, different methods are required for solving these distribution power flow equations. Also, these are more complex in a way that we have to consider everything. We have to model even transformer connections, whether it is star, delta, everything we have to model in the while doing the power flow analysis. Then there are more number of elements here. We have so many. In distribution, in transmission system, we have only limited some, I think, thousands of generators are there, and some thousands of aggregate load that we use. But here, even one distribution system, there can be lakhs of PV, rooftop PV. each will be accompanied by a converter. So the system becomes very huge. The problem becomes a very huge problem. There are so many components: transformer, generators, different types of generators. Then we have to model the converters also. Then there are, apart from AC load, here we have to model only AC loads. Now we have to model DC loads also. Then storage also has to be modeled, which acts both as a load and as a source. So it functions, it has a dual function. That also we have to model. Then the control objective of each converter, that also should be reflected in the equations, power flow equations. And all the equations, they should represent the combined AC-DC system. All these things, they make the power flow problem for the distribution or AC-DC system more complex. So we need methods which are faster also and can give us good convergence for distribution system. So these are the different converter models. I have not given the equations here. This is DC-DC, so we know we can directly relate this current with this current based upon the expression that we know. For buck converter, we know that here it is E to A is equals to delta times E1A. Here delta is a duty cycle. Similarly, we can write for current also. And for other converters also we can write. This is for buck converter. For boost it will be 1 minus delta. And for buck boost it will be delta upon 1 minus delta. Similarly for this also we can write this is a rectifier. So for rectifier we'll have to write that equation. These equations become non-linear. These equations become non-linear. That is also another complexity which is involved in this power flow equations for distribution system. Then, so we talked about modeling of distribution generations also. We need to model them for power flow analysis at distribution level. There are these four kinds of distributed generation. The first is type 1, which can deliver both, which can only deliver P. The solar PV panel or fuel cell are examples for that. Type 2 can deliver both P and fuel. So the synchronous generators, they can be, they are example for type 2. For type 3, they only deliver Q. So only delivering Q, that can be done by the synchronous condensers or compensators. Type 4 is deliver P but consume Q. So induction generator requires reactive power for its operation. That is why it deteriorates the power factor also. And as a result of which we have to use these power factor correction methods. All the industries, they have to use that. Most of the industrial load is this induction generator based. So they have to use power factor corrections. This is the block diagram for the control of DC microgrid. So, do you want me to explain this, or you have understood? You understood? Can you tell me why are we using a PR controller here. Why can't we use PI here? If this we have discussed in previous weeks also. So do you recall? This is a very important thing to remember. Who can tell? Sunil, do you remember?
Yeah, something static and dynamic variables.
Uh, can you be more specific? So, when we use PI controllers, PI we use because these are the simplest controllers that we have. Most of the industrial control processes they still use PI controller. Although we have developed so many advanced controllers, but still we are using PI because of its simplicity and robustness. It can perform much very with good efficiency, and yet it is simple. So that is why we are using PL. So we want to use, but the requirement for PI is here we can see this VD reference and VDC. So can you tell VDC what type of a signal is this VDC? Is it a constant value or it is a sinusoid? What kind of value is this VDC? So DC, this is a DC voltage. So will it be voltage like this? DC will be something like this. There may be some transient in between, but finally it will again settle to a point. It will not continuously vary. These are sinusoid, they are varying with a particular frequency. So these are constant values. Similarly, this reference also a constant value. Reference is always constant. The requirement for PI is we need these DC signals. If the input to PI is DC, we can get it can control. It can function as per the desired requirement. So here the voltage measured DC voltage is compared with the reference to generate a power reference. And from that a current reference is generated for the inner loop, which is here. This is the inner loop. But there are two kinds of transformations that we use. One is Clark's transformation and another is the Park's transformation. So uh, this is a transformation from ABC to alpha beta or vice versa, from alpha beta 0 to ABC, and this is in DQ field. So the here ABC in both the cases are sinusoids. They are varying with the frequency. But here alpha beta, the output for Clark transformation, this is also sinusoid. These are also varying quantities. While the dq are the DC quantities. If we use dq quantities, we can use our conventional PI controllers, and we can do the desired. We can perform the desired operation that we want. But since here we are saying this is the reference current, they use these are the alpha beta quantities. This I alpha and I beta are not DC quantities. The ABC quantities we are converting that into DQ quantities. We cannot use our PI controller here. So PR has to be used. If we use, what happens if we use sinusoidal input, we give sinusoidal input to PI, then there will be a steady state error. Generally what we know from our control theory that integral control will make the steady state error 0. But if sinusoidal signal is given, then the error is not 0. We have to modify this PI by adding few more controllers, lead lag compensators, so we can make it work. We have to design it for particular frequency, the band gap, the bandwidth that we want. All that will decide the design of this PR controller. And this PR controller will be a higher order controller, and its design is also little complicated. That is why we prefer PI. But here, since we are converting them into alpha beta domain, we have to use PR controller. So once we are generating this, so here we are again getting alpha beta quantities. So we have to again convert them into ABC quantity. Because only controller is working in this domain, but actual physical quantities are not in alpha beta domain. They are in ABC domain. We have to again convert them into from alpha beta to ABC domain. These are those quantities, alpha and beta. So you will be having same magnitude, but one is sine and another is cos. If we alpha square plus mu beta square will give us VP. This should be VP. So here we can see this PI is the order of PR is higher. It's a second. This is first order. This is second order. So order is increasing. That will make the controller design little bit complex. Is it okay? Is there any doubt to this point? So, no, yes. So overview is over. Now whatever we have discussed and based upon the week 11 material, we will discuss some questions. And this is the first question. The modes of powerful control strategy is or are. So which one is the correct answer? Can you answer this? We have already discussed this, right? We discussed that flow chart, and in that there were three conditions. Isolated and grid connected. That is correct. In grid connected, we were having two options. One was peak load, another was the off peak. This is the hour. Total there were three modes: peak hour, off peak hour, and then isolate. The another mode. So here I have missed this option, so I will change this. This should also be done. And the next question is this. This is in isolated mode of power flow control strategy, if PV output of PV is more than load and battery is operating with the SOC of more than 90%, then which of this option is correct? PV operates at MPPT, loads are supplied by the conventional grid, battery supplies the load, or PV operates at off MPPT. Correct? So D option is correct. PV operates at off MPPT. I think this we should not forget. I think we have done this. We have gone through this concept in so many videos. This is repeated again and again. It has been repeated. So this we should always remember even after this course is over. Yes, so this we have already discussed. Just a brief summary. Again, so peak hour or the priority in the peak hour is either to supply the grid, because grid is stressed in peak hour. So we don't want to stress the grid further. If we are not able to relieve the stress, at least we should not be aggravating that stress. We should not increase that stress. So either we reduce that stress by supplying power to the grid from the microgrid, or try to draw only minimal power required for the essential loads, because these essential loads have to be met somehow or other. So only power for essential loads can be drawn during the peak hours, and during off-peak hours power is available at low cost. CG is having excess generation, so that excess generation can be used to charge the battery inside the microgrid, and also loads can be supplied so that the stored power in the battery can be used during the peak hours, so that we do not stress the grid during peak hours. If enough storage is available, so even essential load can be supplied using this stored energy. So can you explain this point? CG should not be conventional grid should not be driven into peak demand. What do we mean by this? It is also an important point. So when we are talking about peak and off peak hour, we are saying something like this is happening. So this is a peak time, and this we can say off peak hour, off peak hour. So what does this statement imply? Can you recall?
Yeah, it is when it is in off-peak hour. If you go for battery charging or anything else using off-peak hour, so there may be a chance of it is going to the peak again.
Correct. Correct. So this is correct. So here we are having only one peak, and other time it is off peak. Suppose here or near this peak only, we start charging the battery. Battery is fully discharged, and we keep on charging the battery, and this results in another peak. The curve itself is changing. So again we are increasing, we are putting grid into stress. So already one peak is there. We don't want to have another peak. But this has to be avoided. This we don't want. So this also happened. There was once a pilot project was started in Uttar Pradesh for this, uh, where the household, the domestic consumers, they were given different tariff was provided for these domestic consumers. So it was said that if the price was much lower during the night hours, it's late night. So what happened that most of the people they started using that power during that low price period, and which resulted into a spike, second spike. That is a very practical issue. So that has to be avoided. Then next is the isolated grid. This will happen when there is a fault on energy grid side. It is isolated, and there are two extreme scenarios. If generation is less than the load and battery is also critically low with the SOC, then load shedding has to be done. Only critical load will be supplied. Non-essential load or non-critical load will not be supplied. And second extreme is when generation is much higher than the requirement of load as well as the battery. Battery is fully charged, even generation is much higher than the load, then the PV has to operate at off MPPT because there is no one to consume that power. And this is the same thing. Different modes are based upon different SOC level. Now, next question is two types of HIL simulation are which are those two simulations? Yes, so this is control hardware in loop and the power hardware in loop. Next question is DC microgrid functionalities. Which one of these are functionalities of DC microgrid? It provides higher stability margins, provide more flexibility services, and also provide grid support services. Which one is correct? D is correct. Need to see them. These are those. One is grid support services. So grid support services. You want to support the grid. How can you support the grid by providing ancillary services? There are different types of ancillary services. Which is C. C is for which option? We're saying C. C is correct, but A and B are also correct. So answer is all of the above. ancillary services are provided. The grid support requires these ancillary services, or there are these include these black start services or the voltage regulation, frequency regulation services. All these services are the grid support services. And in frequency regulation, there are three types. Do you remember what are the three types of frequency services? Frequency regulation services. Okay. Sorry. So, yes, one is primary, secondary, and tertiary. Primary is this is the fast fastest is primary. Primary will act immediately. Even before this, primary is inertial support. And this is only possible for the conventional generators. Or if we have some virtual inertia, then that is possible. So first thing which comes into action is this inertia of the rotating mass. Even after that, if the frequency is not within the band, then the primary response will come into picture. And it is based upon the governor action, which is there in each of the generators. The steam valve will be opened or closed as per the requirement. Then secondary services are there, which is based upon the UGC, public generation control. And then finally the tertiary. So can storage provide all these services? Primary, secondary, tertiary? We have discussed in week 3. Storage can provide all these services. Storage can provide all of these because the response time of primary is very small. I think it's 2 to 5 seconds only. Within 2 to 5 seconds it has to operate, and the response time of battery is within milliseconds. So it can act very fast. Similarly for secondary and tertiary, if storage is of 2-hour discharge duration, it can provide tertiary services also. For tertiary requirement is that it should be able to provide for 1 hour, maximum 1 hour. It should start within 15 minutes and should be able to supply for 1 hour. But storage can start within millisecond. So storage has lot of applications. That is why the research in storage is increasing so much. Then we discussed this first option was the stability. Microgrid can provide sufficient stability margin in steady state and transient operation modes. Then flexibility is that possibility of reconfiguring the system during faults. If we have the controller in the microgrid which can detect the islanding, we have seen in previous weeks there are several islanding detection techniques. Once the microgrid detects that there is a fault in the conventional grid side, it is detected and the microgrid is islanded from the main grid. That is a flexibility. So if there are several microgrids, they can act in when they act accordingly and can make different configurations, still providing the loads, supplying the loads. Even during faults on the main grid side, the loads are being supplied by these microgrids. This we have seen islanding detection, grid support is active power regulation, reactive power regulation. This is voltage and frequency. Harmonic attenuation is also possible. In last week we saw different power quality issue. Voltage sag is one of the power quality issue. In that also it can help. These are the different benefits of microgrid connected to grid. Next question is, in a typical DC microgrid, which of the following is not a mode of operation? Which option is correct? D is correct. There are three modes connected, islanded or isolated, and autonomous. Next question. Correct option for the control layers in DC microgrid. Correct. 0, final, second, fashion. So 0 is same as that inertial approach. So the inverter, if they have virtual inertia embedded in them, they can do that. This is the figure which shows this is a 0 level, which is a control of the inverter's variable itself. And this is very fast, less than 0.1 second. As we go up, these layers will take time. So this is the innermost loop, you can see. After that, this will come. So this is the outermost loop, tertiary. Primary will supply this, help in this 0 level also, and also provide this additional automatic load sharing and grid support. Here you can see here also we end up control the ancillary services, microgrid synchronization, and tertiary control layer is for optimization and power flow control. These are not based upon the frequency regulation division that we have seen. It is based upon the different control actions that we need in DC microgrid. In grid tied, so we saw these are the three modes. So here we see this is switch W1, this is switch W2. So when both the switches are closed, that means the grid is connected to the main grid. If SW1 is closed, this is closed, but switch 2 is open. So in that case, what will happen? The microgrid will be able to supply all these loads which are inside the microgrid, AC, DC loads, as well as because this is open, so this load is still connected to this ACC. This load can also be supplied by the microgrid. The DC load, AC load, PCC loads all can be supplied. If SW1 is open and SW2 is open or closed, that doesn't matter. Because once this is open, this becomes a separate. This load is now connected to main grid. So now it is an island autonomous mode. So to differentiate between these two, here in both these cases, the microgrid is disconnected from the conventional grid or main grid. But in one case, it is able to supply the PCC loads, but in the autonomous case, it is not able to supply the PCC loads. Just a minute, I have to put charger to my laptop. Okay, so this question is done. Next question is, which of the following is or are correct about DC microgrid? It consists only of DC bus. DC bus is for interfacing DC source and loads. It operates in 3 modes and it serves critical loads during grid outages. Operates in 3 modes. This is correct. What about other options? Correct. This is also correct. DC bus is for DC sources and loads, and it has to serve critical loads during outages. So critical loads have to be served whether the microgrid is connected to the grid or isolated. They have to be served. So even when in isolated mode, these loads will be supplied by the storage. Or if generation is low, then even PV can supply. Well, why this is not correct? Because we have seen here, this is a DC microwave, but for connecting it with the AC microwave, we need this AC bus. There can be some AC loads also, but AC bus will be there in DC microwave also. Is it okay? CT? Now, this will also be discussed in distributions. Power flow analysis, we have to model different generators also, and there are 4 types of generator, type 1 to type 4. So type 1 generator is, which one of these is true for type 1? One of the above is not correct. discussed this. Still, we are getting different options. So let me again tell the same thing. Repeat it. Type 1 is delivering only P. Here we can have PV or fuel cell. Type 2 is, which one is type 2? Type 2 is delivering both P and Q. Type 2 is delivering both P and Q. Type 3 is delivering only Q. And type 4 is delivering P but absorbing Q. This is important to remember. Please remember, keep remembering. Keep this remembered. Next is direct statement about AC/DC power flow. Which option is correct? A is not correct. You're saying C. Oh, we have to tell correct statement. Think once more and then answer. Still there are 7 different options are coming up. We have discussed this, right? So, to discuss this again. The Newton-Raphson method is for transmission system. Here we are talking about AC/DC microgrid. It is not a good method for distribution system. You cannot directly use it. This is not correct. And we are saying B, 4 types of AC buses, 3 types of DC buses. How many types of AC buses are there? We have 3 types of AC buses, right? One is slack bus, where we know V and delta, then load bus, then PV buses. These quantities are specified on these AC buses. So this is not 4, it should be 3. And what about DC buses? In DC buses we don't have this Q and delta. So we are left with only P and V. So there are only 2 types of buses. One is P and V. At one bus, P bus, or we can say load bus, and the voltage controlled buses. This is also not there. This should be 2. And let us see option 3. Converter modeling is not an essential requirement. So this is also not correct because This may not be required in transmission system. This is only even in transmission system we require this when we do AC/DC power flow because HVDC lines are there. So converter modeling is an essential requirement for AC/DC power flow. In transmission system, although we have HVDC converters, but number of such converters are very. We have how many? Around 10 to 15 HVDC lines out of 6,000 lines. Only this small number of converters need to be modeled. But in DC microgrid, there are several converters. Number of converters to which are to be modeled for DC microgrid or AC/DC microgrid is much higher. So option D is correct. Is it clear? If there is any doubt, you can ask. Okay. Let us see. Questions are over. Today's session has been little short because sorry at my throat. I have some problem in my throat, so I could not. That's why content has been little less today. But if you have any doubt, you can ask. We still have 20 minutes left. We can discuss your doubts. Are there any doubts? Assignment problem. Which problem you want me to discuss? Jay, which problem or entire assignment? Week 11. First question was, in the case of islanded operation of DC microgrid, where the battery is completely charged and the source power exceeds demand, which of the following control is adopted for PV? So the question is, DC microgrid is operating in islanded mode. And battery is charged. And the source power, that is PPV, is greater than load. So what will happen? Options are entire system is shut down. And PV operates at MPPT. PV operates at off MPPT. And PV is disconnected. So which one is correct option? Also C correct. Also C is correct because we are not microgrid is disconnected from grid. Battery is already charged, so even if PV will operate at maximum power point, it will not be able to. That power will not be used. It will be simply wasted. So that is why PV is operated at off amperature. And next question is same islanded operation is there. Battery reaches its lowest SOC, which what is preferable option? PV is operated at MPPT. Another option is additional loads are put on and critical loads are turned off. I'm sorry, non-critical loads. And battery is allowed to drain. Additional loads are unknown. We cannot. Battery has already reached its lowest SOC. So we cannot put on additional loads. It will further reduce the SOC. We cannot go beyond. We cannot reduce SOC. PV which option is correct? This is off MPPT. If it's MPPT, then this will also be correct. Non-critical loads are turned off. This is correct because we want to supply the critical loads. Critical loads have to be supplied, whatever is the situation. Whether they get connected, isolated, they have to be supplied. Non-critical loads will be switched off. Then next question is, we have already done this. Which of the following is a false statement with respect to power flow control strategy adopted for managing energy of DC microgrid? The peak demand reduction, smooth transition between different modes shortens the life of storage system, and unity power factor. Which one is correct? This is false. And the next question is, charging the batteries is preferred during which modes mentioned below? Um, so which one is correct? Battery is charged during which mode? Okay, correct. Because if demand is more, we cannot charge. We have to supply it. That will further increase the demand. The next question is, during off-peak hours, which operation is desired? Supply power to conventional grid, consume power from grid, draw minimum power from grid, and neither draw nor supply remain idle. Hmm. Yes. During off-peak hour, consume power from the grid and charge the batteries. Someone said supplying power to grid. No, supplying power to grid is not correct here. Jay, why are you saying supplying power to grid? During off-peak hours, it's already generation is more than load in the conventional grid. So the grid does not require any additional power. If the microgrid feeds the grid, then frequency will increase. So sixth question is, for developing various control mechanisms for RES-based microgrids, we design open loop control, we design closed loop control, or we design mixed. Yes, Jay, but answer will not be this. Supply power to grid is not correct. Mixed. We don't use mixed. Whenever we are controlling any critical system, we always use a closed loop control, not open loop. Can you give any example of open loop control system? Any example of open loop system? So traffic signal that we see, the traffic lights that we see on the roads, that is an example of open loop control system. Washing machines that we use there also is on open loop. Here everything is determined and it is starts working on that. It is not again and again it is not correcting itself. Next question is, for developing for which of the following is the highest energy consumer? Industrial, commercial, residential. Which consumes highest energy? Correct. Industry is correct. Can you give some example of commercial consumers? Shops, malls, correct. Who determines the next question is, who determines the preferred demand, volume, and time duration? Options are DSO, aggregator, customer, none of the above. Is it DSO? No, aggregator will not decide that. Aggregator will follow the which one is correct? Sunil is saying ISO is correct, but option is not given. What about what do you think? Even I'm not sure about this. I will check and let you know in the next class. DSO or ISO? I think it should be DSO. Confirm the answer for this in the next class. And so, next question is: in the grid connected mode of operation of DC microgrid, the function of L filter is voltage harmonic attenuation, current harmonic attenuation, or both? Correct. So, what do we use for voltage harmonic attenuation? Capacitor. Answer is current harmonic attenuation. So last question in DC, the grid connected DC microgrid control architecture, which of the following level of control is fast? Primary, zero, secondary, or tertiary? Which is fastest? We have already discussed this. Which one is correct? Zero? It's zero. We have seen right here. Here. You can see here. This is zero. In conventional generators, this is inertial supportation. The inertia of the rotating mass will provide this. This is fastest. After that, primary, secondary, and then tertiary. Tertiary is the slowest. Zero level is the fastest. Any other doubt? To prepare for exam? From my side, I have tried almost. I have tried to compile a summary of all the lectures. The questions also, those that are mentioned in each of the slides, they cover many concepts. So the easiest way is to go through these slides, and you can find almost all the topics are covered. Next, if you want to do more, then you can go through the textbook which is available, right? Because you cannot go through all the videos once again. and you can go to the text transcript and you can read that. Suppose you need to some clarification on a particular topic, you can refer the text transcript. Go to that particular topic and read it. Another thing is go through the assignments once again, do all the assignments. Go through these slides. I think that will be good enough. And if you want to cover everything, then better to read the text transcripts also. So I might have left some things. For example, the control logics or even the demonstration part. I have not covered them fully. Just to do a quick overview of each week, I have just made a summary slide. But this will also be very helpful for you. So now you can decide how to what all things to cover. The exam will also be open, this MCQ type computer based exam, so it will not be descriptive. You can, similar to assignment, you can answer the questions. But read the questions very carefully. Sometimes it is false, incorrect, and we choose the correct one. So those are the silly mistakes that we do. Try to read the questions very carefully and then attempt. You'll be having sufficient time to answer the questions. So take your time and then attempt the question. Is it okay? Any other doubt? Okay. If not, I think time is also up. We can wind up the session. Thank you all for joining. The next week will be the last session. So if you want, you can join next week, same time. Thank you.